So hello, and welcome to the fun side of the climate apocalypse. I'm Holly Cummins. I work for Red Hat. My day job is that I help build Quarkus, which is cloud-native Java, but I have a past life as a consultant. And so this talk is based on some of the things that I've seen in when I was a consultant, when I went, it doesn't seem like a very good idea. So hands up if this is familiar. I get charged $2 a month from AWS, and I'm too scared to turn it off and too lazy to figure out, yep, there's hands, too lazy to figure out what's causing the bandwidth. Or I get emails from an 8-year-old WordPress install, and I'm pretty sure it's an on-prem server, but I don't know where it is, and I don't know what it is, and I can't turn it off, but that thing is still emailing me. So a few of you put your hands up, but of course, losing $2 a month to an AWS instance that you can't find, that's for amateurs, really. The leaders in our industry do it a bit better. So here we have Twitter, who managed to forget about 700 GPUs, as one does. I mean, hands up, who hasn't lost 700 GPUs because you just misplaced them? And the thing that's so terrible about this story is GPUs are in demand. We all want GPUs, and there was 700 of them sat there, powered up, using power, and not doing anything at all. And it's easy to laugh at this as something that happens to other people, that other people do, but we have all done this. In 2018, I learned Kubernetes, and so I did what anybody learning a new technology would do. I created a cluster, but I had a bit too much work in progress. So after creating the cluster, I forgot about the cluster that I'd created for 2 months. And then when I went back and looked at it, I realized that I'd created a fairly well-spec'd cluster. This thing was £1,000 a month, and it was just sat there doing nothing while I did my other jobs. So that was a slightly awkward conversation with my boss. And I didn't learn from that experience. So while I was preparing this talk, I had a Mac server for Mac Stadium that I was using for Mac CI, but I'd kind of not quite managed to make it work, and then I got distracted doing other things like writing a talk, and then I went back and looked at it, and it was £150 a month that again was just sat there, burning CPU, doing nothing. So how bad is this problem? Is it just, a few quite isolated but kind of hilarious incidents like Twitter losing 700 GPUs? Or is it something more systematic? Obviously, as rational computer people, we shouldn't be making judgments based on stories on the internet. We should be measure, don't guess. But it's kind of hard to measure this. It's kind of hard to quantify how many things you've forgotten about, because by definition, you've forgotten about them. So this is an actual picture of a zombie. As you can see, you can't see it. That's the whole point. You don't know it's there. However, there is some research that people have done to try and at least surface this in a statistical way. So in 2015, an organization called the Anthesis Institute did a survey of 4,000 servers. They found 30% of them were doing no useful work. A couple of years later, they repeated the survey. They increased the scale, so they did it for 16,000 servers, and the numbers were pretty much the same. A quarter of them were doing no useful work. And when they say no useful work, I should clarify that this is a high bar. This isn't the servers were mining Bitcoin or showing cat pictures. This is they hadn't delivered any information, however low the quality, however value-free, or computing services for 6 months or more. Nothing was going in, nothing was coming out. And so they call these servers comatose servers. They're on life support. They are consuming resources, but not doing anything at all. But there's another category of underutilized servers, which I think is maybe more serious because it's less obvious. And these are underutilized servers. And again, we see this all the time. A while ago, I was talking to a customer, and they were explaining to me that the way they managed their workload was they ran it as a batch job on weekends. But the servers stayed up all week, even though nothing was running. I've spoken to other people, and they have a system that they only use in UK working hours, but they leave it running 24/7. And again, we can quantify this. So the Anthesis Institute found that 29% of servers were active less than 5% of the time. 5% utilization is pathetic. This should make us embarrassed and worried. And if we can generalize this, so we can go from that a third of the servers are only active 5% of the time, and we can conclude that the average server in our industry is running at about 12 to 18% of capacity. We are completely not taking advantage of the computing power that we have available to us. And this matters a lot, because if you have a server running at 12 to 18% of capacity, the cost to you for the hardware, for the cloud, is pretty much 100%. And the cost to the planet is pretty high as well. So even though something is using very little of its capacity, it will be using between 30 and 60% of its maximum power. So we have this disproportionality between how much value we're getting from it and how many resources we're putting into it. And again, we can quantify how much this is costing us, and that the spoiler is it's a lot. So in 2021, there was a study, and they found $26 billion was wasted by always-on cloud instances. If you think what you could do with $26 billion, if you could get that back, you could have ice cream for your whole team for till the end of the universe. There's so much you could do with this money. And the thing is, I mentioned already, this isn't just money. The money is a big part of it, and it's not even just the electricity. So even if these things are running on renewable electricity, there's still a problem, because every piece of hardware that we're wasting has what's called embodied carbon. Embodied carbon is the carbon that it took to manufacture that hardware, and it's a lot. And then, of course, when you have a data center, that data center needs water to cool it, and it's a lot. And then, of course, once you're done with your computer that you didn't really need, it gets to the end of the life and it gets decommissioned, and that generates e-waste, it generates landfill. So we have all of these impacts that come from computation that we didn't even want. And we can put this into context. The Green Software Foundation have an excellent set of principles, the Green Software Principles, and there's 3 basic categories of things that we should be doing to improve the sustainability of our software or of our IT operations. The first is carbon awareness. This is about where you run your workload and when you run your workload, which affects what kind of electricity is being used. The next is hardware efficiency. So this is about elasticity and utilization, but we'll come back to that. The last one is electricity efficiency. So this is really about your software stack. So it's about how you coded your algorithms. Were they efficient? What stack did you choose? Are you running on Rust or are you running on PHP? That's going to make a really big difference. But that middle one, the hardware efficiency, is what we're going to talk about today, because that's all about elasticity and utilization. And the zombie problem, you can call it the zombie problem, which sounds really exciting, or you can call it low utilization, which makes you sound a little bit more serious. It all depends, which you want. Why does this happen? I think there's three reasons. The first is forgetfulness. The second is laziness. And the last one is fear. Now, this sounds kind of terrible. It sounds kind of negative and judgmental. I think honestly, we don't need to be this judgmental. This happens to all of us. So we can reframe these in a more positive way. There is a lack of institutional memory. There are competing priorities because there is always more to do than there is time. And many organizations have a quite sensible risk aversion. But the combination of all of these is the zombie apocalypse. And I was surprised about forgetfulness, but it was something that the Anthesis Institute, when they did that survey, they sort of asked the same question: why does this happen? How could this happen? And their best guess for why a quarter of the servers were zombies was perhaps someone forgot to turn them off. And I think this is exactly what happens. And again, no judgment. Managing machines is hard. Managing machines has always been hard. This is an urban legend, but it did actually happen. It's not a zombie, it's the opposite of a zombie. Many years ago, in 2001, there was a university, and they had this server, and it was a useful server, but when they did the audit to try and connect the physical server to the software, they couldn't find the server. And they eventually found the server sealed behind a wall. They had to follow the cables, and they eventually found it. So you kind of think, if it's possible to accidentally brick a server into a wall, of course it's possible to forget a server in a data center. It's amazing that it's not more than 25%. Another thing that quite often happens is we just don't quite get around to decommissioning, because decommissioning is kind of boring. And quite often the reason that we need to decommission a system is because a project ended. If a project ended, you don't want to invest time tidying up that project. You've got your new project, which is what you're being measured. And quite often as well, business processes change. We used to use this system, now we use the new system, but we kind of don't quite get round to taking down the old system. And that, I think, one of the reasons that we don't take down the old system is sort of the what if, the fear. Another thing that fear causes is over-provisioning. Because no one wants to be the person who under-provisioned the system and caused an outage. So we say, well, I won't get in trouble if we run at 5% utilization. I'll get in a lot of trouble if we run at 120% utilization. And there's really solid technical reasons as well. So if you have sensitive data, or if you are security conscious, then quite often you're working with isolation requirements. You cannot just take all of your workloads and put them in the same cluster. You can't just put them on the same machine. There's technical issues with Kubernetes, for example. So when I first started learning Kubernetes, I imagined that the way we were going to deploy these things was that we were going to have one cluster for our whole organization, and we were all going to have namespaces. But the problem is that CRDs tend to apply across namespaces, and so then you're going to have conflicts. And managing admin rights is, a little bit sensitive. And so what's ended up happening is we've gone from this model where we have the cluster as the sort of the base layer that everything is built on, to the cluster as the unit of deployment, because that's safest technically. But it's also pretty wasteful. And autoscaling is something that really should be helping us with this. But autoscaling algorithms have a bias to optimize for availability, because just like no one wants to be the person who provisioned so that you are running at 120% utilization, no one wants to be the person who writes the autoscaling algorithm that causes an outage. That's not what we want our autoscaling algorithms to do. So, fair. And utilization and elasticity are really quite related. And one of the things that we find with a lot of our systems is that they're not quite as elastic as we hoped for. So what we should be aiming for when we figure out how much utilization we want, we should be aiming for around 70 to 80%. That gives you some headroom, but it's also making good, efficient use of your system. But I mentioned that if the workload goes up and the capacity doesn't increase, then you end up with overutilization. This is the catastrophic case. This is the you are getting sacked in the morning case. Everybody tries to avoid this. And the way to avoid this is to go to this, which is safe, but very, very wasteful. How do we fix it? What we need to do is we need to have the elasticity so that if the workload goes up, the capacity of the system can also increase. So when we design systems, we really should be optimizing for elasticity at every level of the system, not just one or two. Because if we have elasticity, when the workload goes down, we can scale the capacity down and stay at that good utilization. So how do we solve the zombie problem? Well, elasticity is part of it, but it's only part of it. Before we can start looking at that, what we need to do is we need to do detection and we need to do destruction. And this actually sounds quite fun. If you look up on the internet how to handle zombies, what you'll find is the top 5 ways to kill a zombie, and almost all of them involve flamethrowers. Now, how many of you work in regulated industries? About a third of your hands, yeah. So with regulated industries, things are a little bit more challenging. You cannot go into your data center if you have a regulated industry with a flamethrower and start removing the servers. I think it's, I forget the regulation, but you can look it up at home. So we need to be a little bit more clever and systematic about how we do this. So often what we end up doing instead is system archaeology. But system archaeology is a little bit like real archaeology. It can be pretty tedious and it can be pretty hard. One of the least entertaining 4 hours of my life that I have ever had was I had a meeting with the CTO of a UK bank, and they'd sort of summoned us in to help them with their system archaeology. And they had a spreadsheet, and they were going through every single thing to try and figure out what all the workloads were. And this spreadsheet model, I'm sorry to say, is very common. This is a spreadsheet that went around my work quite recently. And you can see that, we have all of the systems and we're trying to figure out who owns it, what's it used for. And then you get lovely comments turning up like, it was assigned to someone and they came back and they said, these assets are unknown to me. I do not know who the owner should be. What do you do with that? You hit a dead end. Or same thing, the person we thought owned these doesn't own them and has no idea who should own them. What do you do? And so then at this point, if the spreadsheet isn't working and if the email isn't working, then quite often the next resort is long emails. So probably all of you have gotten some of these, right? Where you get an organization-wide email that says, we seem to be paying quite a large cloud bill. We're fairly sure that most of this is useless, but we don't know what it is, and we're trying to avoid the spreadsheet. So instead, could you just please go look at your stuff and turn it off if you need to? Again, this is pretty crude. So sometimes what organizations try instead is tags. At least with a tag, you have some metadata that hopefully allows you to connect the server to the function. But I have found that tagging is better than nothing, but it's not really as reliable as it should be because tags tend to go out of date. So you could decide that this is all too much like hard work, and you could go back to the flamethrower approach. And so this is called the scream test. Now, if you are practicing chaos testing, how many of you are practicing chaos testing? A couple of hands. You can extend your chaos testing, and those of you who aren't practicing chaos testing yet, you can introduce it. And instead of thinking about system resiliency and all of those other things that we want to achieve with chaos testing, what we can introduce is the eco-monkey. So the eco-monkey is a bit like the other chaos monkeys, but what the eco-monkey does is it randomly shuts off a server, and it sees who screams. If no one screams, you're okay. You can leave it shut off. I should warn you, the scream is real for this. I heard a story. It was a large IT outsourcing organization, and they were doing an audit of their systems. And inside their firewall, so in the area that was reserved just for their internal IT, they found the server. Nobody knew what it was. It probably went around the spreadsheet. Nobody claimed it in the spreadsheet. So, doesn't seem to have a purpose. Let's turn it off. Awesome. Half an hour later, they got a very, 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 very angry call from their main customer saying, the backbone of our network has just disappeared. What did you do? To which the only response, of course, is, oops, sorry about that. We'll sort it out. This is why risk aversion is a thing. Now, of course, you're not even doing IT unless you have an ops for it. So all of the opses can actually help a lot with this. One of the ones I'd like to call out is GreenOps. GreenOps is increasing in popularity as a term, but it hasn't quite made it yet. So the first time I Googled for GreenOps, I didn't find anything about IT and sustainability. What I found was this. This is a GreenOps. It's a mid-sized trilobite that is mostly found in Ontario in Canada. Who knew? It will get there, though. A more popular ops that is really, really helpful is FinOps. So FinOps is framed and marketed in terms of money, but of course it also has quite a lot of sustainability benefits. So FinOps is really about figuring out who in your company forgot to turn off their cloud, because if you have that real-time flow of financial information, you can then optimize away the stuff that nobody is using. And I really like Backstage for this. So with Backstage, you can have the cost insights plugin, and what that allows you to do is bring that financial information that normally is only at the sort of the CFO level, and actually bring it to the engineers who are responsible for optimizing away that cost. You can also use the Cloud Carbon Footprint plugin, which will allow you to directly look at the carbon impact of your workloads. Both of those, super, super useful. But like I mentioned, detecting these is only half the battle. Because once you've decided something is useless, it's pretty scary to turn it off. You know, the scream is real. And what this can mean is that people often identify zombie servers, but it's just too much bureaucracy to actually get to the point where you can turn them off. So, you know, bureaucracy is the friend of zombies. And even at a human level as well, there's a lot of things that prevent us from wanting to turn these things off. So a lot of us have that personal risk aversion of, you know, why would I shut off my server? Because I might need it later. And there's a cognitive bias here as well. So it can seem scary to turn off the servers, but it also sometimes is just actually kind of painful to turn off the servers. There's a cognitive bias called the IKEA effect. And what the IKEA effect says is if you put work into making something, you feel more fond of it, which we've definitely all seen with, you know, the things that our children make and that kind of thing, or, you know, things that we make that are really not very good, but we made it and we like it. And so we have the same thing with our servers, that once you've put a whole bunch of work into setting up a system, you feel quite attached to it. You don't want to shut it off. But this, you know, even though these factors are there, we need to move away from that. And we need to move to a model which is much more like a light and a light switch. A light switch is the ultimate in elasticity. We never, ever leave a room and say, oh, I could switch the light off, but if I switch the light off, what if it never comes back on again? We have confidence that the light is going to come back on again. But with servers, a lot of us still have this sort of institutional reflex memory that if we turn a server off, it may never be the same again because we thought it was stateless and actually there's state somewhere, and so we just don't want to take the chance. So we keep the servers on. And as well, quite often, getting the server set back up in the same way is just too much work. So we leave the server on. So we need to move away from this. And in order to move away from this, what we need some qualities of service. So turning the system off and on again. It has to be fast. The system actually has to work when you bring it back up. And so that means you need idempotency. It means you need the resiliency. And I started calling this LightSwitchOps. And the good news is, like, in Cloud Native, we already needed those qualities of service anyway, so we're 3/4 of the way there. And I started talking about LightSwitchOps, and everybody went, And then I noticed that now there's an O'Reilly book, Building Green Software, and LightSwitchOps is in that book, and I keep sort of seeing it elsewhere, and other people are talking about it. So it was a very exciting moment because I thought leaders. So LightSwitchOps is really make turning servers off and on as easy as turning the lights on and off, and make it as low risk and as non-scary. So the first thing is you just have to get rid of that scary state. You have to move away from your Snowflake servers and move towards a more GitOps model where you've got your infrastructure as code and you can reliably spin it back up again. Because if you have that, then that means you can spin your server down and you can spin it up and it will be in the right place and it will have the right things. Obviously in the Kubernetes ecosystem, hopefully we're doing a pretty good job of this. So kubectl helps with this, Ansible helps with this, lots of products that help with this. And then the next thing, once you have something that you can spin up and down, automate the turning it off and on again. So it's no use just having the scripts, you actually have to run the scripts. And the way you do these, it doesn't have to be fancy. So one UK bank, they just made it so that when you got a self-service instance, it would self-destruct after 2 weeks unless you renewed the lease. So it was sort of like the Blade Runner of servers. They had a 50% reduction in their cloud costs. You can just time the shut-off. And so a Chicago company, they got a 30% reduction in their cloud bill just from doing this. A Belgian school got a 12,000 euro saving a year just from shell scripts to turn their servers off and on again. So these things can be really simple. Or now we're getting open source projects to support this as well. So there's a project called DailyClean that came from AXA France, and it means that you don't have to learn the cron syntax yourself because no one wants to learn the cron syntax. You can have the front end. And so the way DailyClean works is it just gives you an extra pod in your Kubernetes cluster. I quite like this because it relates to my day job, because wouldn't it be terrible if this extra pod ended up consuming more resources than you were saving by turning the things off? The extra pod uses Quarkus, so it's super, super resource light, which is nice. There's also commercial products here. So I saw recently there's one called Turn It Off. I haven't used it, but I just saw it, and I was really happy to see that there's more products in this area. You can also do auto-tuning, you can do auto-scaling, you can do bin packing. There are some things that seem like they should help, but don't. One of these is the cloud. So in the cloud, we have a bit more elasticity, but it's so easy to forget things in the cloud because they're out of sight, out of mind. You don't even need to brick it up into a wall to forget it. Virtualization, again, seems like it should help, but you still have to turn the virtual server off. And a lot of virtual servers are still running the operating system and not doing anything else, so they're still consuming resources. You need to turn it off. Serverless should help. Not every workload should be converted to serverless because it is a big lift to get there. And with serverless, what you tend to see is that although the workload itself has quite a lot of elasticity, there is a control plane to support the serverless system. That control plane has much less elasticity, and so even though you have the auto-scaling or the serverless scaling on your application, you do need to factor in the cost of that serverless control plane. There are some things that definitely don't help, even though it really seems like they should. One of these is prevention, which is kind of counterintuitive, because surely, shutting the barn door before the horses escaped is the right thing to do. It turns out that if you put really heavy barriers in place to prevent people from being able to provision systems, once they get that system, they are never letting it go. So what you need to do to support the elasticity is you need to have the process elasticity as well. It needs to be an easy come, easy go process governance model for servers. And with all of this, what I think is kind of exciting is that this is a problem, but we're starting to be able to solve it, but we haven't totally solved it yet. And that means that there's opportunities for all of us to innovate. There's opportunities for all of us to make a difference. And if we do that, we'll be saving the world, which is kind of awesome, and we'll also be saving money, which tends to make our employers happy. So it's a win-win. So if you're a user, I would recommend always try and get that utilization up. Aim for elasticity, try and limit your cube sprawl. And dezombify, know what you're using and turn it off when you're not using it. If you're a tool creator, make sure that your tool supports better utilization, again, by having that built-in elasticity and that support for multi-tenancy so that people can do the bin packing. And support dezombification, so make sure that your tool makes it easy for people to see what they're using and easy to throw things out. And with that, thank you very much. The slides are the left QR code, and feedback is, actually, no, I don't know what, I'm facing the opposite way. One of those QR codes is slides. One of those QR codes is feedback, which is very helpful to me and to the organizers. And you can find me at Red Hat and on Blue Sky. Thank you very much.